Welcome to The Explainer. We are jumping right into what is absolutely the most profound shift in software engineering since the invention of high-level programming languages. For decades, programming has really just been an act of translation. You understand a problem, you design a solution, and then you painstakingly render it into syntax. But that era of curly braces, it's ending way faster than anyone predicted. Today, we're transitioning from writing code to expressing intent, and we're trusting intelligent systems to actually do the typing for us. So, let's get right into it.
Here's a quick look at our roadmap for today. We'll start with the shift from syntax to intent, compare vibe coding with agentic engineering, and then explore the agent factory model. After that, we'll dive into the AI-driven SDLC, contrast the roles of conductor and orchestrator, and wrap up by breaking down the economics of AI.
Section 1. From syntax to intent. Let's look at how our primary communication with the machine is fundamentally changing. Take a look at this rapid, shrinking gap between human effort and machine autonomy. Back in 2021, we were completely amazed by simple autocomplete, just your editor guessing the next few characters. But fast forward to 2025 and 2026, and we're dealing with autonomous agents that can clone repositories, plan multi-file changes, and submit pull requests entirely on their own. To put that into perspective for your daily workflow, as of early 2026, an estimated 41% of all new code is AI-generated. That is a massive shift. To really wrap our heads around this autonomy, let's break down the foundational AI agent loop. An agent is fundamentally different from a standard chatbot. A chatbot basically just sits there and waits for your prompt. But an agent, it runs its own continuous cycle. It perceives a goal, plans the steps, takes action using tools like APIs, observes the results, and then iterates. It actually self-corrects until the goal is met. This loop is the beating heart of the entire new software paradigm.
Section 2. Vibe coding versus agentic engineering. Now we need to unpack two very distinct ways developers are integrating these agents into their workflows today.
You might have seen this viral quote from Andrej Karpathy. It perfectly captures a trend that just swept the community. He described a workflow where you fully give in to the vibes, embrace the magic, and forget the code even exists. And it resonated, right? Because ad hoc prompting feels incredibly liberating. But applying this carefree, casual mindset to absolutely everything, well, that introduced some serious risks, especially when we talk about enterprise software.
So, what is vibe coding exactly? It's really defined by its lack of structure. You just describe what you want, and when something inevitably breaks, you just copy and paste the error back into the prompt. It's blazingly fast, but your verification is basically just a casual, hey, does this seem to work? Check. Now that's totally fine for a weekend hackathon, but telling your CTO that you're vibe coding a secure payment processing system, yeah, that's going to set off some massive alarm bells. It introduces severe security vulnerabilities and hidden financial risks simply because the logic is unverified.
That brings us to the disciplined solution for production, agentic engineering. The main differentiator here isn't whether or not you use AI, it's how the AI's outputs actually get verified. Agentic engineering ensures a structured AI implementation under very strict constraints. You're building a robust testing harness using formal architecture docs, automated test suites, and strict CI/CD gates. Instead of just eyeballing the code, you are enforcing systematic quality assurance at literally every single stage.
Section 3. The agent factory model. Let's look at an entirely new metaphorical journey for developers.
Notice the hard separation of responsibilities here. You, the developer, operate up in the top zone. You are defining specs, designing guardrails, and reviewing the final output. The AI agents, they are down on the factory floor doing the heavy lifting of implementation. You are no longer the one assembling widgets by hand. You are the factory manager designing the assembly line. In this model, your output is no longer just code. Your output is the actual system that produces the code.
When an AI agent makes a mistake, our first instinct is usually to just blame the language model. But the math tells a totally different story. The model is just the raw engine, making up roughly 10% of the overall system. Your harness is the other 90%. That harness includes your orchestration logic, your rule files, your observability tracing, and your sandbox deployment configs. Engineering that harness, that is where the real work happens.
Managing this factory effectively requires a brand new capability, context engineering. You have to deliberately balance static context against dynamic context. Static context, like your absolute core security guardrails, is always loaded. It's highly reliable, but it's token-heavy and expensive. Dynamic context is loaded on demand, like specific task skills, making it super efficient. If you want a really actionable step to start practicing this today, isolate your absolute non-negotiable rules into a static architecture document, and move your task-specific logic into dynamic fetchable skills. Treat this boundary as a first-class architectural decision.
Section 4. The AI-driven SDLC. With our factory built and the harness configured, how does this actually alter the software development lifecycle?
When we compare traditional syntax-based methods to intent-based AI systems, the implementation phase shrinks drastically. We're talking from weeks down to literally minutes. But because implementation is so fast, your bottlenecks shift entirely. Suddenly, requirements, system design, and rigorous evaluations take center stage. Requirements are no longer these static documents slowly passed between teams. They become a dynamic, real-time conversation between the human and the AI that produces a working prototype simultaneously.
You can validate this exact shift by looking at the infamous 80% problem. AI agents are fantastic at rapidly generating 80% of a feature, but they hit a massive brick wall on the last 20%. The complex edge cases, the subtle integrations, and those tricky architectural trade-offs. The errors models make aren't just simple syntax mistakes anymore, they are conceptual failures that look completely correct on the surface. And this is exactly why your human judgment and architectural oversight are more critical than ever. You use AI for speed, but you reserve human attention for correctness.
Section 5. Conductor versus orchestrator. Let's look at what your daily routine actually becomes in this new life cycle.
You are going to constantly shift between two distinct modes of working. First, as the conductor, you're super hands-on, working synchronously inside your IDE, giving keystroke-level direction for immediate logic generation. But then, as the orchestrator, you step back to manage complex systems. You provide high-level, goal-oriented delegation to autonomous agents. You might hand off a massive code-based migration to an agent, walk away, and then just review the pull request over coffee hours later.
Mastering this orchestrator role means building daily habits around 4 critical technical skills. Specification, which is defining tasks without any ambiguity. Decomposition, breaking large features down into agent-sized units. Evaluation, quickly assessing the output quality. And system design, creating those robust feedback loops. Learning intent-based communication isn't just some minor workflow tweak. It is absolutely the core career skill for the next decade of software creation.
Section 6. The economics of AI. Finally, how do engineering leaders actually justify these investments to senior stakeholders? The financial reality really boils down to capital expenditure versus operating expense. Vibe coding feels super cheap at first. It has very low CapEx upfront, but it hides massive OpEx over time through heavy technical debt, subtle bugs, and completely unmaintainable code. Agentic engineering flips this entire model. It requires high CapEx upfront, meaning you're investing real time and money to build the harness, the test suites, and the intelligent model routing. But once it's built, your operating costs plummet. To measure long-term ROI, you just have to look at how beautifully the system scales once you've engineered an autonomous framework that you can actually trust.
As we wrap up this explainer, I want to leave you with a crucial question to evaluate your own daily workflow. Are you just prompting an engine and hoping for the best, or are you truly engineering the harness? Embracing agentic engineering isn't just about writing faster code. It is about building the systems that build the software. The transition is happening right now, so make sure you are the one managing the factory, not just pulling the levers. Thank you so much for exploring this massive shift with me.